Claude. Are you there? There you are. You're still muted, though. You got to unmute. All right. I've got coffee as well. Hopefully everybody on the line does. We've got, looks like 41 so far, Claude.
Good, good, good. Can you hear me?
Mm-hmm.
Great.
Yep. I will also say this is so far our best attended webinar. It's projected to be. There's over 200 people registered. So
over 200.
Yeah.
Holy smokes.
Yep. So that's good for us.
Wow.
Yep. So we're excited to present this topic today, obviously, and others are excited to hear about it. So
very good, very good.
Yeah. All right. So what'll happen is you can see my screen is being shared right now. Once I'm done with the intro stuff, I will click the stop share button, and let me make sure my settings are such that allows you to just, let me stop it a second right now. Any panelist can start sharing. Okay, let me just change that. So even if mine is still showing, you can share, but once I hit the stop button, then you share your show and it's all yours.
Okay, sounds good. Good deal.
All right. I'm going to mute a second and we'll start in about 4 or 5 minutes.
Good, sounds good.
All right. Based on my clock, looks like we're at 10 o'clock here. Welcome, everyone. Good morning again. Steve Walkus with the Michigan Concrete Association. Glad to have you folks on the line this morning. We've got a very popular topic to be discussed this morning in our webinar. So welcome to those of you who are logging in. We've got over 200 people registered, and it looks like over 100 people and rising currently logging in for the webinar this morning. So again, these webinars are brought to you by the sponsorship of some of our member companies here at MCA. Three in particular that are sponsoring the entire series: Superior Materials, Levy Company, and St. Mary's Cement. And this topic today, we're thankful we have a webinar sponsor for today's topic. That's Oshkosh. As a ready-mix truck manufacturer, they've sponsored our conferences and workshops in the past, and are sponsoring today's topic as well. Which brings me to my next slide here. The format for today, if those of you that have not been in one of our webinars that we're doing throughout the month of the second half of January, all of February, and we're now scheduling into March, is we do about a 1 hour topic. We allow an hour and a half total. Your questions and answers, please use the Q&A button on your Zoom control software to type in a technical question for our speaker. Claude, would you like me to interrupt you, or do you want to take those at the end?
I guess a couple of thoughts. Why don't we take them at the end? And the reason I say that is, I'll discuss that in a minute, but this presentation, it's actually a 90-minute presentation, and I do it for Dave Hollingsworth's level 2 class. So I think it's a long one, so I'm going to apologize right now. So let's, I think maybe we'll just take them at the end.
Okay, sounds great. If we don't have time, if people start dropping off because they have other commitments, we can create a log of all these and submit those after we submit the CEH certificates. If there are any other comments, there is a chat window as well. If you want to talk to us as panelists, you can send us a comment or question. The chat window is available as well. But if you have a specific technical question on the topic for Claude, please use that Q&A button in your software. Those of you that are logged in, we're over 130 and rising still. If you're on for the entire time, the majority of the entire time, you'll get the credit for the CEH, and I will email those out later. Our speaker today, you see Claude here on the line. He's with LafargeHolcim. He's been a technical service engineer there since 2002. Prior to that, he was with a consultant, Wisjani Elsner, for 3 years, and St. Mary's Cement for 6 years prior to that. In his job with LafargeHolcim, he provides technical assistance to their customers in the Great Lakes region. He's essentially a liaison between the cement plants and their customer base, those that purchase their powder for use in concrete. He has a bachelor's and master's degrees, both from Lawrence Tech in the Metro Detroit area, and has been very active with ACI for a number of years. In fact, he's active on 4 different committees at the national level with ACI, as well as he's been active with the Greater Michigan chapter of ACI based in primarily Southeast Michigan. And again, thank you to our sponsor for today, Oshkosh Corporation. And with that, I will turn it over to Claude. Thanks, Claude.
Good deal. Good deal. Thanks, Steve. Appreciate that. Let's do this. Okay.
Yep, looks great.
Okay, good deal. So I guess I should, like I said, let me apologize right now. This presentation, I've been doing this presentation for the MCA for probably about 19 years now. Dave Hollingsworth asked me to do this presentation. It's kind of a rapid fire presentation of different field things that you'll see, field issues, field concerns that I've probably seen over I guess my career. So it's kind of it's kind of a light presentation. Dave Hollingsworth, you know, at the MCA, he heads up the certification. So if you've taken level 2 in the past 19 years, you've probably already seen this presentation. It's more of a presentation where we're just going to, you know, slowly click through, like I said, the different concerns that can come up. A little bit about, I guess, about a little bit more about the presentation, I guess I would say is, that's why I think usually when I'm doing the presentation live, I know I'm going to be doing it next month for Dave again, but there's a lot of interaction between the classroom and myself. But again, I think, and I know Dave blocks out 90 minutes for the presentation, but I think we will, it'll be best if we just try to do the questions in the end. So I guess even before we get started, I would say the vast majority of these pictures that I'll be showing are my own. I do every now and then pick out a slide, maybe from PCA or something like that, but for the most part, all these are going to be my own. You know, why would you want troubleshooting basics? I think it's important. You know, I don't think anybody wakes up in the morning and says, I'm going to make bad concrete today. No, nobody does that. But unfortunately, you know, we mine materials from the earth. So, you know, the opportunity for pop-outs, for example, they're going to be there. So unfortunately, we do come across things and issues. And I think that's why we basically need a troubleshooting discussion. One of the first things, though, that I kind of would like to talk about would be, you know, what do you do when you get called out and you go out there and you look at something and you go look at a site, you know, what are some things you want to consider before you even, you know, start doing anything, I suppose. Well, as soon as you get to the site, one of the first things I like to do is just sketch everything out, just make some observations, and believe it or not, sometimes when you just kind of make, it doesn't have to be a great sketch, but just you make a sketch of what it is you're looking at. Sometimes just looking at that sketch will tell you what's going on. So believe it or not, it may or give clues to what's actually happening there, right? So take your measurements, take your photographs in a manner that it can help you tell your story later. So you'll see that in all the photographs I take, I always try to have maybe a ruler or something that will help me kind of, again, tell my story later and support the narrative I'm putting together. Last, when it comes to drawing your conclusions, one of the things I always like to do is I like to draw my conclusions based on industry standards. And what I mean by that is the Concrete in Practice. It's a series of documents put out by the NRMCA, and they're great documents. It's 1 8.5 by 11. And it's going to cover just a host of different topics. If you don't have a copy of the CIPs, you certainly want to get a copy of those. Other organizations, certainly the MCA has a little technical tab you can go to and find out some information from the MCA. Certainly ACI, PCA, organizations like that are going to be great for drawing your conclusions, right? So first up, I always show this picture, and the reason I do this is because usually students are usually still coming into the class. This is, I think Dave does this presentation, or has me do this presentation like at 8 in the morning, so everyone's usually coming in a little bit late. And a colleague of mine sent me these photos. She was not involved in these, but nonetheless, I know Concrete Construction magazine, I think, printed like 1 or 2 of these one time, and I think it was they're pretty remarkable. I think. What's amazing about these photos is, the concrete looks great. I mean, the concrete's durable and probably sound, but you can see here that, certainly there were some issues going on that certainly need addressing. Okay, so first up, I think I'd like to talk about pop-outs. Pop-outs are an issue that I've seen, from day one when I started my career, and unfortunately, they continue to show up. So what are pop-outs? Well, pop-outs are conical voids observed in the surface of the concrete where a portion of the aggregate remains intact in the concrete. And so what's actually happening is in some aggregates, you'll find deleterious material. And they will be typically lighter, than the more sound material. So they may float, find their way to the more top half of the slab. And what's interesting about these materials is, these aggregates will take on water, and we know water, when it freezes, it expands 9%. And we know concrete is strong in compression, weak in tension. So what will happen then is that little aggregate, that little deleterious aggregate, it will actually, with the ice in it, expand and break, and it'll blow apart the top of our concrete there. So if you change to a laser. So what's interesting about pop-outs is when you'll go and you'll see a pop-out, often, if you get there soon enough, you can see little fragments of the deleterious aggregate, sometimes just adjacent of the pop-out right there. What's interesting about pop-outs is, again, we're mining all these materials from the earth, and the thing about pop-outs is they, economically, it's difficult to try to remove all deleterious material from our aggregates. So our specifications, they recognize this. For example, both ASTM and even Mdot specifications will recognize that, we can't remove all deleterious material. It's economically, very difficult. I mean, you can buy washed sand, for example, or something like that. But for the most part, the likelihood of having some deleterious material in your aggregate is, the opportunity for it can exist. So sometimes what you can do is, if you come upon a situation where you see pop-outs in a surface, you can reference one of these specifications. They'll tell you how much is allowed per cubic yard. And then what you can do is you can go out there and, let's say it's a 4-inch slab, you can kind of determine what would equal, a cubic yard of concrete. Let's say the concrete had, 1,500 pounds of sand. Well, then you can look at the specification and determine, how much of that 1,500 pounds, due to that specification, can be deleterious. And if you can go through and maybe pick up, each one of those and weigh them, would it exceed or, pass that specification? The vast majority of the time, the pop-outs you're going to see are going to pass those specifications, right? So it's so again, it's kind of it's an aesthetic problem, but it's an issue that we do have in concrete. Okay, so keeping in that thought process of aggregates holding moisture, and then now maybe flipping over to something that the pavers might see, would be decracking. And what's decracking? Well, that's this time the aggregate is going to take on water, and this time it's going to it's not going to show itself for a good number of years, maybe 3-5 years, but this coarse aggregate is going to hold some water, and then as that water turns to ice, again, it's going to expand 9%, and it's going to rupture the concrete. You can see in this photograph here, here's our coarse aggregate. It took on some water, and you can see as it then cracked the aggregate, and then once it cracks the aggregate, it fractures the concrete. Once it fractures the concrete, it starts letting in more water, and it kind of just builds on itself. When you first walk out and see this pavement, you'll see sometimes that the pavement, probably not the best picture here, but the pavement will begin to show cracks, kind of in a manner like where it'll kind of curve around the joints. What's actually kind of happening there is, again, if you had this, you had a slab, the slab was on ground, and maybe we weren't taking water, we weren't properly draining the slab, so we have water underneath the slab. You have your joints, and maybe they weren't cleaned and sealed, so we have water attacking the slab here, obviously rainwater on the top of the slab. Well, then this corner, like I said, it is going to be wet, and if we have coarse aggregate that are going to be susceptible to decracking, to taking on water and allowing that water to freeze and rupture it, again, you'll start to see the cracking. I think this next picture here might maybe show it a little bit better, where again you see some of this cracks where it will kind of take a manner such like this. So what are some tips with decracking? Well, we can certainly test our coarse aggregates before we put them into practice or into service, or even choosing coarse aggregate with a good history of successfully putting out pavements that don't fail to decracking. You can see here, this is probably a little bit better of a picture of what I was trying to explain when you start to see the cracking, kind of circling out from those joints. Again, so these are examples where, again, the aggregates, whether they're pop-outs, I kind of see in Michigan are probably more limited to fine aggregate. Decracking would be probably more akin with the coarse aggregate. But either way, these are aggregates that, due to their makeup, they're allowing water to take into the particle, and then the particle not being strong enough, and then blowing apart at the surface. So, kind of moving past decracking, another surface issue we come across would be blisters. So, what are blisters? Blisters are hollow, low-profile bumps on the concrete surface. Now, these blisters typically range from maybe like a size of a dime up to maybe a couple inches kind of thing. Hence their name, blisters, right? So you can see here's the blisters that are haven't broken open yet, and in this picture here, I've got some blisters that the cream has broken away, exposing the blister. So they're likely to form if the subgrade is cool and the concrete in the bottom of the slab sets slow. Sometimes if air entrainment is used at higher than normal doses, and I have a star there because you may say, well, sometimes in interior floors, why would we use air entrainment? I'll talk about that in a minute. Sometimes you may have a mix that's rich in fines, perhaps a mix lean and cementitious content, or even any operation that's going to bring excessive cream to the surface. And here again, a little bit of a blister. So I think this picture better describes what's going on. So what's happening is we have our slab of concrete. So let's this would be a slab of concrete in section, and what's happening is as this concrete is fresh, it wants to bleed and release air. So as it's bleeding and releasing air, if we should trowel this surface too soon, again, while it's still bleeding and releasing air, we can create this cream at the surface here that will trap all of this air and bleed water. And as it traps it, it will eventually create this blister. You can see here in this actual concrete section here, the blister here. And the whole idea is that any finishing operation that takes place while the concrete is still bleeding, is you're going to find out through this whole entire presentation is undesirable, right? So we want to let the concrete complete its bleeding before we start doing any type of finishing operations. So blisters have an ugly cousin, and their name is delamination. And what this is basically blisters. However, these blisters are much larger in size. These blisters are, they can be up to several square feet. But again, it's the same principle. Again, kind of ranging several square feet. But the idea here is the concrete still is bleeding and releasing air. And perhaps if we trowel the surface too soon, we're going to lock all of this air and bleed water into this little zone right here. And as the concrete eventually hardens, it won't have much durability in this zone, and it'll break away, causing the blister or the delamination. So some tips for avoiding blisters and delamination. Don't seal the surface too early. Again, allow the concrete to bleed and release its air. What's interesting about blisters and delamination, when you go out there and you observe this type of situation, a lot of times you'll see here that the sand, the fine aggregate, is washed clean. You can take your hand and almost pick up, and you'll pick up clean sand, because what has happened is, again, all that bleed water and air, as it was coming to the top, it literally washed clean those sand particles. So kind of a good telltale sign of that you've had blisters and delamination. So again, you want to more of a finishing type of issue, and just something to be aware of, because you certainly can come across it. I talked about do not use air entrainment unless you're going to have de-icing salts. So we haven't talked about air entrainment. I talked about that a bit later in the presentation. But what's good about air entrainment is in its plastic state, it kind of acts as ball bearings, where it will help the concrete become more fluid, right? Those microscopic air bubbles work with one another, again, to just make the concrete appear to have even more slump, we'll say. So sometimes it's desirable to maybe put 0.5% dose as opposed to a full dose. Now the problem with that is every now and then that half dose can sometimes turn into a full dose, and when that happens, the likelihood for blisters on an interior floor that's going to get hard trowel, it's you're going to greatly increase the risk of having blisters, right? So that's why sometimes they'll say, don't use air entrainment unless there's going to be de-icing salts, meaning unless it's going to be somewhere outside. But I know, again, the idea is, well, it definitely makes the air entrainment makes the concrete a little slicker for the finisher. Avoid placing the concrete on a subgrade that's less than 40 degrees Fahrenheit. Again, it's the idea of that cool sub base, allowing the air and bleed water to slowly come up. So a warmer sub base would be preferred. And then lastly, protect the surface from premature drying. Again, which is cure. You've got to cure the concrete, right? Okay, so next up would be curling slabs. So a curled slab is the distortion of a slab, and typically what I see would be in an upward bending motion. Slab curling is going to be caused by a temperature gradation or a moisture gradation in the slab, meaning click right through here, as the slab on ground dries out, you would have a situation where maybe the bottom of the slab is staying moist, the top is being dried out. So what's going to happen is those corners are going to want to curl up, right? This can sometimes happen with an increase in water content, an increase in the volume paste of your cementitious. Aggregate type 2 can also promote curling. Thin slabs and long joint spacing, again, issues that can promote curling. So again, what's happening is the whole idea where, and this is kind of exaggerated, but the bottom of your slab would stay moist. The top of the slab, for whatever reason, is drying out, and that's allowing the corners of the slabs to want to curl up. This is a real problem sometimes in warehouses. This is I mentioned earlier when I started the presentation, it's a good idea to sometimes sketch things out. I recall one time going out looking at a warehouse floor, and at all the intersections of the joints, you saw a crack. And what was really kind of going on, though, if I can use this again, it was curling. So the corners were curling up, right? And just due to the weight, it wasn't even they weren't even rolling any equipment over these floors yet. But just due to the weight of the slab, it would crack and bring the corner back down. And like I said, everywhere where there was an intersection of joints here, the weight of the corner would crack and or would fall back down, and you get these cracked corners. Again, sketching something out, kind of, and looking at it, from the bird's eye view, you can kind of see what's really going on there. So again, the idea, curling up, the concrete can't handle its own weight, it cracks, falls back down, right? So this is a downward concave slab. I gotta admit, in all of my years, I don't think I've ever come across this. I guess this would be where, the top stays moist and the bottom dries out. I don't know, maybe that can happen somewhere in the deep south, maybe where a very hot subgrade or something. Or maybe you do an excellent job of curing or something, and you know, the top stays moist and the bottom, you know, happens to dry out. But yeah, I gotta admit, even I haven't really come across many of these. Okay, so what are some tips to avoid curling? Use the lowest slump practical. Avoid retempering. So what retempering is, you know, let's say the concrete shows up, and for whatever reason we need to give it a little bit of a drink. It's allowed, but there are certainly some requirements that go into giving that concrete a drink, and so let's make sure we're fully aware of what those requirements are. Use the largest practical maximum size aggregate to minimize drying shrinkage. Again, just the mix design can be conducive to curling slabs. So we certainly want to use the you know, when we're selecting our mixes, and we know we're doing floors, we want to use the maximum size aggregate. Use a damp absorptive subgrade. You know, again, the idea of the slab, you know, drying out and then curling up. So you definitely want to avoid, you know, having a dry subgrade. Proper strategy when you're using vapor retarders. You know, there's the whole idea would be, you know, vapor retarders. When we're using a vapor retarder, let me back up even more. You know, this concrete on a vapor retarder, you know, this moisture, this water has one way out. It's not through the vapor retarder. It's going to be through the top. So be cognizant of that, and realize that you know, that you know, we have to allow for this bleed time. We have to allow for this bleed to get through there. I know floors go down sometimes a little bit wet, but we should try to avoid that. Some other tips would be, I talked about excessive bleeding, right? We want to avoid that. Proper jointing techniques. What's tough about this presentation, a lot of it builds on one another, but we don't talk about jointing until a little bit later. But regardless, again, keeping that joint spacing to what's good for the concrete. A lot of times you'll go out and look at a warehouse floor, and the joint spacing follows the columns. Well, sometimes the columns aren't what's best for the concrete, so you need to take that into thought as well. Lastly, cure. It's so important that we cure the concrete. You know, so many times we don't see proper curing, but a lot of these issues can be avoided with proper curing. Okay, another concern we can come across is dusting. Dusting's a funny one. It's hard to come across good photos of dusting. I think everybody, anytime I've seen a presentation on dusting, I know everybody uses this picture here from PCA. So what is dusting? Dusting is the formation of powder or chalk resulting from the disintegration of the hardened concrete surface. So this is where our concrete can powder under our foot traffic. It can easily be scraped with a key or something like that, and it's just a punky, undurable surface. What are some causes? Finishing in the presence of bleed water, and anything we can do that can, you know, cause us to have a surface that's going to be weakened, and finishing in the presence of bleed water. That's something you're going to hear throughout probably this whole presentation. Insufficient curing, again, an issue that's going to bring about a weakened surface. The big one that I see sometimes, though, with dusting would be the use of unvented heaters. And so what's going on there? Sometimes, and I see this a lot in the wintertime, you know, concrete will be placed in a building, or it could be a residential basement, it can be a warehouse, and we're heating the space with you know, those torpedoes or those salamander heaters, something like that. And well, these types of devices will give off exhaust gases. And the carbon dioxide from these exhaust gases, they'll settle on the concrete and cause carbonation of the surface. And that's really what we're talking about with dusting. And the surface is usually is failing due to carbonation. And so anytime we're using these types of the equipment, gas buggies, things like that, make sure that we're in a well ventilated space, right? So if you are going to be using a heater, you've got to vent that heater to the outside. So what are some tips to avoid dusting? Use a 5-inch slump. And a lot of times when I'm going to be mentioning slump, by the way, that's a 5-inch water slump. So certainly, you know, if you're going to place a floor, I understand, you know, not a lot of floors are going to say go down at 5 inches, but you use your water reducers to maybe take it to another couple inches, right? You want, again, water isn't something that we want to have in abundance, right? Don't bless the surface. But again, the big one here with dusting would be ensure adequate ventilation of gas-fired heaters. But on the plus side, I see this more often than you can imagine, where go in the person's basement floor. A lot of times it seems to be with a walkout. I don't know why, but for whatever reason, it was placed in the wintertime, and you know, the heater's going or something, and the floor dusted. Or sometimes I see it even in garage floors. As a matter of fact, the last one I looked at was actually a garage floor. It was dusted, you know, pretty bad. But what's nice about, or where we're fortunate with dusting, I should say, is there are some commercially available floor hardeners. And what these are products that you can, they're liquid in nature, and they can be rolled or sprayed onto the carbonated surface. And that concrete that had suffered the carbonation, you know, once you put these chemicals on it, it'll turn it hard again, and it'll make it a good, durable surface. Now, if it's severely dusted, you know, you may have to grind the surface or something and then put a topping. But I would say most of the times I've come across dusting, you know, it's always been, you know, remedied with a commercially available surface hardener, and they work well. So it's certainly something you can be aware of. Okay, so moving along to another type of issue we come across would be some commonly observed cracks. You know, everyone always says there's 3 things you need to know about concrete. You know, 1, it's going to get hard. 2, no one's going to steal it. And 3, it's going to crack. So I guess the question would be, you know, why does concrete crack? Well, concrete, like other construction materials, expands and contracts and deflects under load. And when we don't accommodate for this movement, concrete will crack. And what's nice about concrete is, again, like I said, it's very strong in compression, but very weak in tension, right? And this is why it doesn't want to take movement very well. And this is why we have cracking. What we really need to know about concrete is that it's going to obtain its largest volume when it's first placed. And then from that point on, it's going to want to shrink, right? And so we first place it, and from that point on, again, it's always going to want to shrink. And if we don't accommodate that desire of the concrete to want to shrink, we will get cracking. Why is it shrinking? Well, the water that we use, like I said earlier, we use a lot of water in concrete that we probably don't even really need. And a lot of that water, we call it water of convenience. And a lot of the water we use is mainly a vehicle to place the concrete. So when we look at water cement ratio, like you know, a typical water cement ratio at maybe like 0.45 or 0.50, there's a lot of water in there that we really don't need for hydration. I mean, we can get down as maybe like 0.25 is maybe all we really need for hydration. So the rest of that water, again, it's used as a vehicle for placement. So you can imagine at some point, all that water that's obtaining a volume in our concrete eventually needs to leave the system. So again, as it leaves, that concrete's going to want to shrink, right? And temperature also, so it's variations in temperature are also going to cause that concrete to change in volume. And when we restrain that change in volume, the concrete will crack. So first up, let's talk about cracks in basement walls. You know, cast in place walls, they're excellent for living space. And when I say basement walls, this isn't just residential. I can think of many commercial buildings that have basement walls as well. So this certainly isn't just a residential type presentation. But so we can have temperature and drying shrinkage, and if in these walls, and if we don't provide for that movement, we will get cracks. Other issues with basements could be non-uniform support at footings, expansive soils, things like that. Again, are all going to cause us to have cracking in our walls. Backfilling too early, heavy equipment near the perimeter of the construction. Those are issues that can eventually lead to cracks in walls. A big one, lack of joints or improper use of joints in a wall. Sometimes, it's very rare I see a basement wall jointed, but in a few minutes I'll show you that really, well, it's code, and we should be considering jointing our walls. The National Association of Home Builders, they require that corrective action be taken anytime there's a crack in a basement wall that lets water through. So, so it's definitely, I told you a minute ago that the basement walls make terrific living spaces, but at the same time, we need to make sure that we, do what we can to make a crack-free wall. So what am I getting at here? Well, this is I hope you can see it okay, but this is a little site plan, and you can see there's a residence here and the garage, and there's a lot of concrete here. They have a patio, a driveway, some walkways, and the takeaway is all of this concrete was jointed. We were smart enough, we knew enough, hey, we need to joint this concrete. So the question becomes then, how come we don't know enough to place joints in this concrete, right? As the concrete's being driven to this site, it really doesn't know if it's going into a driveway or a patio or a basement wall. So if we're smart enough to know to joint this, why don't we joint this? And I don't know how well you can see this one here, but this is called a reentrant corner crack. Anytime we have a corner in concrete, boy, that's just a ripe place for cracking. And again, so we know about this. What is something we can do better? Well, for example, an 8-foot tall by 8-inch thick wall should contain vertical joints at a spacing that are 30 times the wall thickness. And I think when you crunch this math, it basically means 20 feet. So when you multiply the 8 times 30, again, you're doing this in inches, you divide by 12 to get to feet. So the good rule of thumb is 20 feet or so, you should be looking at having a joint. The joint should be a quarter of the wall thickness, and the joint should be sealed. Horizontal reinforcement should continue through the joint. So what am I getting at? I couldn't find a good picture, so I'm going to, hopefully this is translating well. The whole idea would be that as you're placing your forms, what you'd want to do is have a chamfer here in your form, a wood strip or something that you can have on this side of your interior of your form, and then on this side of the exterior of the well, it's still the interior of the form, but on the exterior side. Then the idea would be once you strip the forms, you would have this chamfer in the concrete. This would create your joint. It would be easy to put sealant in there. It becomes easier to maintain. You can even put a water stop if you wanted to through here. But this is a much better detail than letting Mother Nature put a random crack, right? So what we're getting at is this. So the idea would be, instead of having those reentrant corner cracks that always happen off the corner of a window or maybe a door or something like that, you can certainly put in a joint, just like we did here. And again, these would be contraction joints, and you're going to want to follow the recommendations. But like I said, if you space them out, at 20-foot intervals or something like that, you would certainly make a much better wall, right? So what are some tips for cracks in basement walls? Uniform soil support, that kind of goes without saying. Use that moderate slump. I know you're going to say, who places basement walls at a 5-inch slump? Well, again, that would be our water slump. Get the rest of it with your water reducers. Follow proper curing practices. Again, these walls here, there's no reason these walls can't be cured. They can be spray-on curing. It can be as simple as use that inherent moisture that we talked about earlier that's in the concrete. Visqueen or polyethylene sheets over these walls, secured at the bottom. That's a great way to use the inherent moisture to help cure that concrete, right? Okay, quick sip here. I see some questions coming in, I believe, so hopefully it's kind of drinking through a water hose right here, but we'll get through it. So the next type of cracking would be these plastic shrinkage cracks. And so what are these? These appear soon after the concrete was placed and finished, and the concrete is still plastic. They're usually parallel to one another, and they're about 1 to 3 feet apart. And quite frankly, they're kind of usually just 1 to 3 feet in length. They're not very serious looking cracks. They're relatively shallow, and they typically don't penetrate the depth of the concrete. They are kind of a close-up view. This is probably a little bit better picture. Well, why do these cracks happen? Excuse me. They happen because there's a rapid loss of water from the concrete surface before it has set. So what's happening is typically the wind is, well, we talked about the bleed water, right, earlier. So as the concrete wants to bleed and come to the surface, the wind is just taking that moisture right off the surface and causing cracking, right? The surface is drying quickly, and the concrete is still plastic and weak, and that's how these cracks form. So what's interesting about these types of cracks is we know that a wind in excess of 5 miles per hour, a day with low relative humidity, and a relatively high ambient temperature or even concrete temperature, these three aspects are likely to give you these plastic shrinkage cracks, right? So sometimes you really don't see these in an area, maybe in a residential area or a place where there's maybe a lot of windbreaks, whether it be buildings or whatever. But certainly, this example here was an airport runway. And the other thing that's interesting about this is, I don't know, you can't see these cracks too well in this picture. In the background here, there's a windsock, and often these cracks will line up with the direction of the wind. So it's all kind of related, right? So what's going on? And I think this picture didn't translate too well, but so I just told you a second ago that the wind, the humidity, and concrete and ambient temperature are going to play a role in plastic shrinkage cracking. So we have an empirical type of chart here, and I remember when these charts were in many ready mix producers, plants, and things like that. You can see these on bulletin boards. And what's interesting about this chart is we can predict with with a pretty good amount of variability the likelihood of plastic shrinkage cracks occurring. So if we know the air temperature and we know the relative humidity, we can plot that in this quadrant. So I looked at Lansing, for example. A day in Lansing, the average temperature we'll say is 75 degrees. The humidity, though, is only like 10%, so it's very low. But even at that, we don't have 10%, but we can even say we'll go to the 20 regardless. And then if you went over to concrete temperature, let's say the concrete temperature was like 70 degrees, and then the wind in Lansing in May is like 10 miles per hour. You can then read down to the 10, and then you read over this way, and then you're going to come across the rate of evaporation. And the concern here is anything from 0 to 0.1, and you're safe. You won't be dealing with any plastic shrinkage cracking. However, when you get into the 0.1 to 0.2 range of rate of evaporation, in this range here, the 0.1 to 0.2, that's kind of a gray area. It's likely, but not 100% going to happen kind of thing. Now, 0.2 and above is you're most likely going to have some trouble with plastic shrinkage cracking. So the point of the story is, on any given day, pretty much in Michigan, you're going to fall in that 0.1 to 0.2 range. Okay, so the likelihood of plastic shrinkage cracks in Michigan is it's always kind of an issue, and it's just something that you need to be aware of, and just kind of have it on your radar. What are some factors that could reduce this rate of bleed in the mix? Well, high cementitious content, high fines content, reduced water content, entrained air, which of course we're going to have, high concrete temperatures. All these types of issues have the potential to reduce the rate of bleed in the mix. So what are some tips to avoid plastic shrinkage cracking? Dampen the subgradient forms when conditions for evaporation exist. Prevent moisture evaporation with fog sprays and windbreaks. I can only think of, I think, one time where I saw fog sprays being used, and those were on sidewalks of all things, right? I was really amazed. Cover the concrete with wet burlap. Consider these polyethylene sheets between finishing operations. That was an interesting one. I hadn't thought of that. I've got a star there because anytime you use polyethylene sheets, the opportunity for kind of a discoloration on the surface does exist. So you want to be aware of that. Use cooler concrete in hot weather and cure as soon as finishing is complete. So these types of cracks, what I've been told, I've never done this myself, but I've been told that when it does happen, sometimes someone will have a wood float on hand, and if they see it, they'll kind of just very gingerly try to work through this crack and trowel out that crack. So it again, it's more superficial than anything, and but definitely you can see that in Michigan, we're kind of in that gray area where it can certainly show itself. Okay, another form of cracking is craze cracking. So what's craze cracking? Craze cracking is sometimes called shallow map or pattern cracking, and this is where we get a fine network of random cracks on the surface of our concrete. They are approximately 1/8 inch in depth, and they're most noticeable on steel or over-troweled surfaces. This is more of an aesthetic issue. These types of cracks, they're just unsightly more than anything. They rarely affect the structural integrity of the slab, and really they don't even really affect durability too much. But I think when you first see them, if you're not aware of what this is, if you're a building owner, they definitely would cause your eyebrows to raise, like what is going on, right? I mentioned they're unsightly when wet, and a lot of times when calcium chloride is used as an accelerator in the concrete, the likelihood of getting crazing is a little bit more advanced. So what are some tips to avoid craze cracking? You see them more on a hard troweled surface, and what's actually happening is the very near surface is shrinking. That paste layer is shrinking, and again, not properly cured, things like that. So use a moderate slump, and try not to steel trowel exterior concrete, because that's going to help promote craze cracking. Some other tips, excessive manipulation of the surface. Again, creating a lot of cream at the surface, too wet of a mix, finishing in the presence of bleed water. Anything that you can do that's going to, again, create too much cream, because all that cream eventually is going to need to start to shrink and cause our craze cracking. Again, cure as soon as finishing is complete. Settlement cracks. Settlement cracks are a tough one. Often it's well after the fact, well after the concrete's placed, they're real difficult to deal with because again it's just so much after the fact. A lot of times settlement cracks are began because the subgrade that we placed the concrete on wasn't properly prepared. So a subgrade needs to provide uniform support throughout the entire slab, and topsoil and soft spots should be removed. If the subgrade is not uniform, a subbase of sand, gravel, or crushed stone or another granular material should be employed. Our subbase should be sloped for drainage, and it should be free of frost, ice, and snow. So again, with settlement cracks, often it'll be somewhere way before the concrete even showed up where we'll have some issues. The other issue with settlement cracks that I find are downspouts. You can imagine that this concrete was certainly placed properly. We'll believe it was because there's no way they would have been able to place it with this washed out area here. So chances are they properly formed it. They did everything that they were supposed to do right. But here you have this downspout that washed everything out. I guess here I said they tried to do everything right, but chances are they didn't have they probably had some soft spots, and perhaps they should have made a good subbase of sand or gravel or crushed stone. So you know what, quite frankly, I don't think they did it right. My guess is it's a sidewalk to the front of the house, so chances are it'll probably what's going to happen is they'll come in and put topsoil on the side here, and then they'll plant sod or whatever, and no one will be ever the wiser of this issue. Will it crack? Probably not, because it's only going to be having foot traffic in and out of the house. But something like this happening in the driveway, now you can be talking about issues with cracking. Oh, by the way, for those of you who know Dave Hollingsworth, that's Dave. Probably again a photo from well over 20 years ago. Again, it's these downspouts. Like I said, they can cause us quite a bit of issue with settlement cracks. This was an example where, although it doesn't look so severe on this side, what was happening is as water would come out of this downspout, really, this photo doesn't do it justice, but the earth kind of tapered up. So the homeowner would complain there was always a large puddle here. That's this side of the garage here. Well, you can tell that it went through and undermined all of this slab here. And on this side, and on the other side of the garage, it was even worse on this side. So again, a situation where they probably had something very similar to this washout happening here. And again, you get your settlement crack. So again, downspouts are an issue. We need to be getting the water as far away from not only our buildings but our flat work. An extension onto these downspouts are always the good practice. So something you want to be aware of. Okay, so now we have some cracks due to improper jointing. So I talked a little bit earlier that concrete expands and shrinks with changes in moisture and temperature, and the overall tendency is for the concrete to want to shrink. Okay, so what do we do with flat work or concrete in general, I should say? We provide joints. We can place those joints by forming, tooling, or sawing those joints. And here's an example of sawing, tooling with a hand tool, and an isolation joints here, which we'll be talking about. Now, the first type of joint I'd like to introduce is a contraction or control joint. And this is where in the concrete, we create a weakened plane and we are going to tell the concrete where to crack. This weakened plane in the concrete is going to regulate where the cracks take place. So the idea is by placing either a saw cut or a hand tool joint, we're going to tell the concrete to crack underneath this. And the idea is when looking at this joint, it's very clean. It can be easily maintained. If you needed to, you can put a backer rod and sealant. Tires coming over this, whether in a warehouse or something, will provide better durability than a random crack. A random crack here, it'll eventually spall, become a maintenance issue. Aesthetically, it's not very pleasing. So there's many reasons why you would want to joint the slab. What's important to know about this is the depth of this joint needs to be a quarter of the thickness of the slab. Okay, so whatever the thickness is, it must be 1/4 that thickness. And it can't be less than 1 inch. And what my point here is, here someone came across, they were doing a nice job, they thought, and they were saw cutting, but certainly they weren't the proper thickness. It's certainly less than 1 inch. And when you do that, Mother Nature is going to put it in herself, and that's what's tough. Here everything was, you tried to do it right. The right mix is sent to the site. Everything, they waited for the bleed water, we'll say, they cured it, they did everything properly, but here you go, you don't follow the standards of the industry, and like I said, Mother Nature will put it in for you, right? And in Mother Nature, her eye isn't as very aesthetically pleasing as ours, I guess, right? Here's an example of, again, a residential application, of a hand tool joint. And I don't know how well you can see on your screen, but the joint properly worked. If you remember, the crack is supposed to take place kind of in the bottom of the slab underneath the joint. But at this point, it then took off and it went into its own direction, right? And you can almost see, just standing in this picture, you can almost see the bottom of the joint. This is a little bit of a close-up view. Again, if I can see the bottom of the joint, chances are it's not going to be 1 inch, right? So you can see the crack worked properly through here, or I should say the joint worked properly because it cracked. But again, Mother Nature, she took it on her own, and you can see right here that it just simply didn't work. A lot of times what I'll do is you can take like a business card or something, and you can put it down into the joint, grab the card at the top of the concrete, pull it out, and you can measure that distance, and you can determine, I think in this case, the joint was like something like 1/4 inch deep. And so clearly 1/4 inch isn't going to provide you the joint that you really need. Well, here's an example where clearly the person came through, he probably took this class and he knew that, well, I got to cut 1 inch deep. He cut 1 inch deep, but here you can see it didn't crack. Well, what was going on here is, we didn't talk about it yet, but there's some recommendations we need to adhere to as far as the joint spacing. And so again, we had someone, they did everything right, placed the concrete properly, waited for the bleed water, cured it properly, and instead they got a crack going into a direction that just is not at all what they wanted. I'm looking here, this is, I see I have an MCA pen in this photograph, so my guess Steve probably has a number of these pens in his desk. But so what are we talking about here? The joint spacing of these slabs needs to be 24 to 36 times the thickness of the slab. So a 4-inch slab needs to be jointed in 8 to 12 foot panels. So what's interesting is when you go out and maybe you're looking at something, and a slab on ground, again, it can be commercial or it can be residential, but as soon as we start getting away from that 8 to 12 foot joint spacing, we're asking for trouble. And a lot of times you say, well, where do these empirical type rule of thumbs come from? I think we're in a world where we need to calculate everything. We want everything to be hard data, right? Well, this empirical data, this picture here kind of gives us a hint to where it comes from. And a lot of times when we're placing maybe like a large condominium project or large apartments or something where they're placing large mat concrete, what'll happen is, again, like I said earlier, Mother Nature will come in and crack the concrete. People placing these large apartments, they really, they're gonna put down floor covering, they're gonna put down carpet, things like that. So, they're not really interested in the cost and the time involved in saw cutting. So they're just gonna let it crack. But what's interesting, again, I don't know how well you can see in your picture, but like I said, Mother Nature, she's going to put these into almost perfect panels. And when we measure those panels, they fall into an 8 to 12 foot span. And so a lot of these empirical type of definitions that we come up with, they're just found through, I hate to say trial and error, but they come through experience of observing these issues, right? Another issue that we want to avoid are sharp corners. Again, basically through observation. When we make these sharp corners, maybe at the near the street, concrete doesn't like that. Again, it wants to be in squares or rectangles, and these sharp corners are going to crack. Something else you need to know about these squares and rectangles: the length should not be greater than 1.5 times the width. And a lot of times you'll go out there and you'll look at panels, and due to the configuration of the site and the concrete that was being placed, the panels needed to be, maybe made smaller or something, or somehow they couldn't get away from rectangles. But if you start to get away from this, where one side is greater than 1.5 the other side, the likelihood of a crack is very great. So again, these are contraction or control joints, and we need to follow these recommended practices. Here's an example again. I don't know how well you can see this crack on your screen, but they wanted to do some really interesting, intricate things and some patterns over here, and it got really big. And again, getting away from the standards of the industry, you're going to get cracks. Another type of joint is called an isolation joint. And these joints separate slabs from other parts of a structure. So this is where we bring the fresh concrete in, and we're dealing with maybe concrete columns, we're dealing with walls or footings, we're dealing with structures that were there before the plastic concrete showed up, right? Well, we have to isolate the concrete from those existing structures, because if we don't, the concrete's going to want to crack around those existing structures. So for example, here's a concrete column, and these folks knew that if we're going to place this concrete floor, we don't want to place the concrete directly up to this column. So they've isolated the column with these isolation joints, and if you don't, you're going to basically get some random cracks coming off that column, which again is undesirable. So you see this sometimes when concrete is adjacent to a building. For example, what we're talking about here is these bituminous fiber strips. And so what happened here is, we have some fresh concrete. Someone, you see this unfortunately in a lot of removing and replacing of driveways. And what I mean by that is, maybe have an older home, and the folks saved up, for a new driveway. The new driveway gets placed. The contractor tries to do everything right. Unfortunately, he omitted the bituminous fiber strip adjacent the house right here. He omitted the isolation joint. The fresh concrete gets placed, and that concrete, it's going to want to adhere to that brick. Well, we talked about concrete wants to shrink. So as that concrete wants to shrink, it's going to pull, and the house isn't going to move, So unfortunately, I don't know how well you can see it here, but you get a crack right around the house. This one might be a little bit easier to see. Again, there was no isolation joint adjacent to the structure. The fresh concrete gets placed, no isolation joint, and you get a crack right around the perimeter of the structure. I see this one quite often where someone will have a garage, they'll have the driveway. This is an isolation joint here. Again, it's the bituminous fiber strip. This is the front of the driveway heading this way. So they had the isolation joint through here. From here down, the concrete looked great. They placed the concrete, a little sidewalk adjacent to the garage, no isolation joint. The concrete, adheres to the brick. Concrete wants to shrink. It can't take the garage with it, so then you get the cracking. So isolation joints are important to, they're very important to the success of concrete and not having these crack issues. So hopefully you're still with me, and we're going to bring it home with probably the two larger issues. And these are issues, scaling. And scaling and mortar flaking, I should say, are the two issues that I think as an industry, maybe I'm talking more so to the residential market here now, that gives us kind of a black eye. These are news clippings from, this was actually from the Cleveland area. This was back like in the 1990s. And there was kind of a scaling, huge scaling issue. And I even recall that some ready-mix producer owners and things were spending a night in jail. It was just an absolute mess out there. I would say locally, the amount of scaling I would say is down. I think our industry is getting better. We're understanding things a little bit better, and we're doing a better job with scaling. There's no doubt about that. So what is scaling? This is a photograph of a scaled surface. So scaling is the loss of the concrete surface mortar surrounding the aggregate particles. The aggregate is exposed and hardened mortar peels away from the surface of the concrete. So what's happening here is it's a physical action, again, caused by hydraulic or water pressures from water cyclically freezing and thawing within the concrete. When the pressures exceed the internal tensile strength of the concrete, scaling will result. It's so much of the issues we come across, deal with water, right? So I've mentioned air entrainment a few times in the presentation, and I'm going to assume there's probably even some admixture folks listening right now. I don't know. So I'm going to give my version of what's going on with air entrainment, because I think it's important to really understand what's happening with air entrainment to fully appreciate how to avoid scaling. So I like this picture because it's actually a very old picture. It's from PCA, but I think it helps the narrative of what's going on with scaling, or I should say air entrainment. So if you can imagine that we have a section of concrete. So we just took some concrete, sliced it in section, and we're looking at the section of the concrete. What we can do is we can put a chemical admixture into the concrete when the concrete is plastic, and that is, one of those admixtures is air entrainment. And the air entrainment is going to produce microscopic bubbles. And these bubbles are going to, when the concrete's plastic, I mentioned earlier, they're going to roll around on one another, almost like ball bearings. And again, they're going to make the concrete very fluid and things like that in their plastic state. These bubbles are strong. They're of a certain size, of a certain dimension, and even of a certain spacing. So it's really pretty amazing. So these bubbles are kind of rolling around. The concrete's plastic. Well, at some point, the concrete's going to become hard. So what's going to happen then is those microscopic bubbles, they're going to create a tiny chamber inside the concrete, a tiny microscopic chamber. So we know that's what's photographed, or that's what's depicted here. So if you can imagine, this is hardened concrete And right here is a microscopic chamber created by the air entrainment bubble, right? Well, at some point, well, we also know that concrete is very porous, right? Or it has capillaries, we'll say. So the surface of the concrete has a lot of capillaries. And what those are these very tiny passages. And what these capillaries do is we see these where, like maybe on a hot summer day, you put some water on, you sprinkle some water onto your sidewalk, for example, and that water seeps into the concrete and it remains dark for a couple of minutes. Well, what's happening is these capillaries are taking that water in, and there's so many of them that's what kind of gives the dark appearance, we'll say, of the surface of the concrete. So all these little capillaries are passageways from the surface of the concrete into the very near top of the surface of the concrete. Okay, so again, we have this empty chamber created by our air entrainment bubble, and we have this capillary or this little pathway from the surface of the concrete. So now what's happening is, how does this help us with scaling? Well, on a day like today or the past couple of days, if the surface of the concrete should get wet or with snow and ice and things like that, this water is going to enter into these capillaries and just kind of sit there for right now. So you've got water inside this capillary and it's just sitting there. Let's say it gets cold enough, maybe at night or something, or again, even during the day, like today, that ice, it's going to want, or I'm sorry, that water is going to want to turn into ice. I mentioned earlier that ice expands 9%, right? So believe it or not, this capillary, which is going to contain water, when it turns into ice, it's going to want to expand 9%. So it's going to keep expanding into this capillary, eventually find its way into this empty chamber, and it's going to turn into ice inside this empty chamber, which is pretty remarkable when you think about it. So here's the surface. So the surface of the concrete is frozen. We have ice inside this capillary, and we even have ice inside this tiny little chamber here, right? Well, what then happens is the sun comes out, it gets warm, and this ice will then revert back to water, and it's going to escape the system in the form of a vapor. So it escapes the system, and it doesn't cause any damage to the surface of our concrete, right? Because it did all of its expansion inside this empty chamber. Well, now you can imagine if this chamber wasn't there. So if we can erase this chamber, and all we have are these capillaries, because we know the capillaries are there. We know that. So erase this chamber, allow the water into this capillary. So now when it turns to ice, what happens? Well, it's going to break apart this surface of or I should say this mortar right here. It's going to break apart at the surface, and it's basically going to cause us scaling, okay? So these extremely strong expansive forces caused by the formation of the ice cause us the scaling, like I said. What's interesting though is, so what do? We throw de-icer chemicals, right? But what's interesting about these de-icer chemicals is they increase both the saturation of the concrete and the number of freeze-thaw cycles the concrete endures. So, I mean, this is significant because I took this photo probably about 3 weeks ago, and other than a little bit of frost on the ground, we hadn't had rain or snow for quite some time. But what I thought was interesting is I saw this de-icer on the ground, yet look how moist the de-icer is keeping the concrete. So the concrete right through here, it's going through more freeze-thaw cycles than the concrete is over here, right? And if we had a situation where for some reason maybe we didn't have proper strength, or maybe a little issue with the air entrainment, or maybe we didn't cure the concrete, this area is going to be more susceptible to scaling. So when we use de-icers, you have to be very careful because again, it was very dry, hadn't rained or snowed in a long time, but yet it's keeping this area moist, right? So let's talk a little bit about scaling. I guess maybe now I'm talking more about the residential market here. And ACI 332, there's, believe it or not, there's actually a code. And a lot of folks don't realize that there is a code for residential concrete construction. I've served on this committee well over 20 years. And I can tell you that Michigan, for example, is going to fall into the very severe category when you open up and look at this code. And exterior concrete in a very severe environment, according to this code, needs to be 4,500 PSI. Additionally, any concrete, according to this code, needs to have a water cement ratio less than 0.45. The slump needs to be 4 inches. Again, this is your water slump, and you can certainly take it past 4 inches with your water reducers. But again, a lot of folks I think don't realize that there is a code, and when we're placing concrete, we should be following the code. You don't want to be in violation of the code. The code also recognizes that SCMs are good at reducing the permeability of concrete. And they give us maximum percentages of SCMs that can be used, again, according to the code. What's interesting is if you look up PCA, if you Google, prevention of concrete and scaling, PCA will tell you that you need a minimum of 564 pounds of cement. So what's interesting is sometimes, I'll come across situations where, I'll see concrete going down for driveways or sidewalks or something like that, and maybe it's 517 pounds of cement, and the person may be getting their 4,000 or 4,500 PSI, but there's other issues that the cement is giving you that maybe you're not getting. Compressive strength is one measurement, all right? And even though that 517 mix might be giving you, your 4,500 PSI, there's other issues that perhaps you might be hurting yourself on and maybe not even really realize it, like soundness, abrasion resistance, durability, things like that don't show up in compressive strength necessarily. So kind of what's interesting here, though, is when you start looking at some of these other documents, I told you earlier that CIP, those are great documents for looking up information. Well, they have a document on scaling. And so both PCA and NRMCA, they're going to tell you that all you need for scale resistant flat work is 4,000 PSI. But then I just told you you've got the code telling you 4,500 PSI. My guess is when I was in school, they always taught us to use the more stringent should govern, right? So in my opinion, I think I support using 4,500 PSI for residential work. Okay. Something that's also important to realize for residential work, or for concrete in general here really, is to have a real strong understanding of your aggregates. And what I mean by that is, these aggregates, and I know a lot of folks will say, well, we've got bin probes and things like this that determine the moisture factor of our aggregate. But what I'm getting at is, those aggregates, as we're bringing them into our concrete mix, there's basically, there's 4 different states that aggregate can be in, from oven dry all the way to damp or wet. Now, certainly oven dry, that's created in the lab, but I guess what I would say is somewhere around here can be really, really dry on a hot summer day, So the reality is we could be bringing aggregates into our mix that maybe on a hot summer day that maybe they're not oven dry, but maybe they're a little bit past air dry. They're thirsty aggregates. Well, what those aggregates are going to do, if you bring them into your mix and they're very thirsty, they're going to take water out of that mix that's supposed to go, for the cement hydration. And what's going to happen there is the contractor, he's going to need to retemper or add water because, the aggregates are consuming too much water. On the other side of that, we can have a day where, boy, it seems in Michigan here, it feels like it rains, 2 weeks in a row or something, and we could be bringing very wet aggregate into our mix. Well, what's happening there is your mix is designed most likely in an SSD state or saturated surface dry, but you're bringing so much extra water in that at this point we have more water than we want for the hydration process. So I guess the point is, if you're relying solely on your bin probes to give you this information, that can be an issue. And I'm saying that can be an issue on those really, really stark days or the points of the year where it's just blazing hot, or those really, really wet season where it's very wet. So if this information that I just kind of outlined is a little bit fuzzy or you're not clear, I'd certainly say, talk to your suppliers, your vendors. We can certainly help you with some of this information. Or if I can put a plug in for the MCA's level 2, you'd certainly want to take that class, because I know they cover this information in detail. But I think really having a handle on this, and maybe that's why I think our industry has maybe gotten better with scaling, is maybe we do have a better handle on this information, and that's good, because it's very important. Again, do not finish in the presence of bleed water. So what are some tips to avoid scaling? Clearly, sometimes you'll go out and you'll see a driveway or something that was supposed to have a swirl finish. This was not a swirl finish. This was just bad finishing, and clearly finishing in the presence of bleed water. Don't do it. Curing, I know I don't have a lot of time, but curing is probably one of the most significant things we can do for our concrete. And curing deals with basically two things: temperature and moisture content. And temperature is probably the easier one of the two to deal with. Most of our concrete goes down at a good time of the year, but you want to make sure that your concrete endures a good temperature and moisture content for 3 to 7 days. For example, now moisture content is probably the more difficult of the two. In this picture here, they were using polyethylene sheets. This was the risers for the big house. It was kind of interesting. As soon as they would place the concrete, they would place the sheeting down. I think they left it down for like 3 days, and then they would move on. In cold weather, as far as temperature goes, you can't see it all that well, but they were using insulation blankets. So certainly insulation blankets are the best to use when dealing with cool temperature. Moisture content, though, is a tough one. We want to keep that thing moist. We want to keep our concrete. Again, it doesn't matter if it's flat work or a bridge or a wall. We talked about basement walls too need to be cured. Again, so for 3 to 7 days, probably the most widely used would be a spray-on type of compound, a surface film, and that would be something like this. Now, this is a road paving application, but certainly the proper application or the proper technique, I should say, for any type of curing. It's easy. The white pigment simply tells the applicator where he has sprayed and where he hasn't. So certainly an excellent way to cure the concrete. But some of the things that I think we sometimes forget is concrete also needs a 21-day air cure period. So during this time, we shouldn't be exposing it to freezing and thawing. And also, I should mention that in a very severe environment, a sealer should be applied. So there's a lot of things that need to be done to our concrete. And what's important to remember about this 21-day air dry period, that's in addition to our curing period. So when you kind of add it all up, you're really talking 30 days are really what's important. The first 72 hours are critical to the concrete's strength and durability. Even the days after that. And what I'm getting at here, though, is in a very severe environment. So let's say you place some concrete on September 15th, and you say, well, it was a beautiful day on September 15th. But you got to keep in the back of your mind that what's it going to be like on October 15th? You know, how are the nights going to be, those first couple weeks of October? And that's what we really need to be thinking about. We can't just be thinking about, we delivered the concrete today, today was a beautiful day. I think for the success of concrete, we really need to be thinking about it well past that. I want to come back to this point quickly that, anytime we're using rock salt, we certainly don't want to have people slipping and falling on icy pavement. So that's safety is paramount. But what's important to realize is, we shouldn't have this. The real takeaway here is when you're using salt or de-icers, whatever you're using, you should, once it turns the ice to slush, you should shovel it up and you should remove this, and then you should dispose of it. It's nothing fancy. I live in an old community, so I still have alleys, right? So I just kind of throw it in the alley, and I mean, it's fine. But the reality is you don't want to have what I saw a few weeks ago. This is just going to, promote scaling. Okay, I've got about 2 minutes left, and the last one I want to show is scaling has kind of an ugly cousin called mortar flaking, and this is what mortar flaking looks like. What mortar flaking is, it's the peeling away of the mortar directly over a flat particle. Okay. This is not pop outs, because when you look at this, if you remember when I talked about pop outs, part of the aggregate pops out as well. That's not what you see here. I mean, all the concrete around mortar flaking is very sound and durable, but you still see this aggregate particle. So what's going on there is again, bleed water. As the bleed water is rising to the surface, it gets caught underneath this aggregate particle, and what happens is this bleed water cannot replenish this mortar above this particle, right? So this mortar up here, it kind of dries out, especially if we don't cure it. So if the concrete isn't cured, this mortar will then shrink and have low durability, and then it'll crack apart. And then what you see left is basically this stone particle. So that's the issue with mortar flaking. So this has been kind of a whirlwind. I had to talk very fast, and I suspect there's some questions. Like I said, nobody wakes up and says, I'm going to make bad concrete today, or I'm going to, purposely finish in the presence of bleed water. I think, these issues happen, but I think quality is never an accident, but the result of good intentions and sincere efforts. So I think the reality is, we can make good concrete, and we do. So I just wanted to leave you with some. I've shown you so many horrible pictures. I have had a chance to, even in an indirect kind of way, work on some interesting buildings. And I think Michigan is rich in excellent concrete pavements. I mean, we have terrific pavements all over the state. We have beautiful concrete buildings. And so I just want to leave you with with the thought that here's a nice bridge. I actually submitted this bridge for one of those MCA awards. It didn't win. I don't know how, because this bridge won some national awards. So I don't know what happened there. But again, we do make some beautiful concrete, and we can thank the Michigan Concrete Association for all of its support in the things that we do. So with that, Steve, I think I'm out of time, but I don't know.
We are, Claude, but I'd love for you to answer a couple of questions. I answered a few.
Okay.
I either typed in or answered a few in the Q&A or in the chat. I'll go through a couple real quick.
Okay.
Does rock salt have a negligible impact on the potential for scaling as long as the concrete meets strength, water cement ratio, entrained air, etc.? Essentially, as long as the surface is not overworked to affect the water cement ratio and air content at the surface, should the use of rock salt be fine? And does the age of concrete have an effect on that?
I guess my feeling would be, like I said, I use rock salt, but like I said, the thing is, once it turns the snow and the ice to slush, the thing is, you got to shovel it up and dispose of it. And if you do that, you're going to be fine. The problem is, like I showed you in that photograph, It's when you leave it there, right? If you leave it there, like I mentioned, the weather was beautiful, or we still have some frost on the ground, but you saw that it kept that sidewalk moist. So guess what? That concrete is enduring. That little area there was enduring more and more freeze-thaw cycles that the other parts of the concrete were not.
Yep.
So I personally do not have a problem with rock salt. I use it, but like I said, maybe I'm a nerd, but I shovel it up and I dispose of it. So I think I hope that answers it.
Yeah, it does. Another hopefully quick one. Joint lengths and widths also consider the slab thickness.
Yeah, I mean, joint lengths and width. So you certainly need to be 24 to 30 times the thickness of the slab. And as long as you stay to those, so I mean, if it's a real thick slab, well, then obviously you get to make your joints, larger in spacing. But certainly you want to, always stick to the industry recommendations and the standards of the industry, and you'll be safe.
Okay. Next one, when we construct a concrete pavement approach to an existing asphalt pavement, what is the most common practice regarding the placement of an expansion joint?
You know what? I really don't know. I guess I would say maybe Steve, you can handle that one.
Typically, what I've seen done, even if you're at an intersection, and the standard there is to put an E-joint at the spring point, the tangent point where the curb return, the radii comes in, and run an expansion joint across the roadway, the side road or main road, whatever you're looking at. What I've been able to convince folks is that, if you go transition back to asphalt within 3 slabs or so, 1 to 3, maybe even 5 slabs, there's no reason to put the expansion joint in, because the asphalt, full depth asphalt pavement will be your expansion. It may end up with a hump at over 20 years, but that'll be milled and resurfaced typically within that time anyways. So only when you have a lot of concrete going back do you need that expansion joint. So typically, if you're going concrete right into asphalt, we generally don't see an expansion joint within that area, because the asphalt will have some give to it. Next one, a lot of folks state concrete will crack no matter what. How true is this statement based on accurate research and factual assessments? In other words, can you totally prevent unwanted cracking by better mix design, mixing, placing, finishing, or does that not exist at this time and there will never be concrete that does not crack?
Yeah. You know what? It's amazing what the advancements that we have in concrete. There are admixtures that we can use to, here I told you a minute ago about joint spacing, right? Follow the standards of the industry. Well, I know there's some admixtures out there that you can employ in your concrete that, you can take that joint spacing and make them even greater. So I guess what I would say, that question is yes, concrete technology is always advancing. The science is out there. I'm sure the people listening right now are probably, rolling their eyes or want to say something. But so I guess the short answer would be yes, there are things we can do to make that joint spacing larger. But the reality is, we do need to joint concrete, because just the pure nature of concrete is going to want to shrink. So we need to take that into consideration. So I hope that answers it. I don't know.
Yeah, I think so. Another one, we'll try to wrap this up fairly quickly, folks. For road paving, is there such a thing as applying curing compound too early? What is the right time to apply cure?
You know what? I'm going to defer to Steve again. I think he probably has more experience in that one.
What I've heard is in general, it's never too early, but all specifications in regards to pavements primarily say, and I should say most specifications state that you apply the curing compound once the bleed water has disappeared from the surface. So if there is bleed water and you're getting a lot of bleed water, yes. Most mixtures nowadays don't have a lot of bleed water. Therefore, you can't hardly even tell when that may or may not occur. So nowadays, with most modern mix designs, with the use of water reducers and low water cement ratios, you typically aren't seeing any bleed water, so there really is no concern for applying it too early. It really depends. Most specifications still have that in there as far as bleed water disappears, then you apply curing compound. But if you wait too long or it never appears and the concrete dries out, that's worse than probably applying it too early. The early application of curing compound typically does not cause that delamination or blistering. That's more of a finishing related operation from what I've seen. And then the last one here, real quickly. Do you have any thoughts on staining on concrete, reddish stains that may appear after a while? Have you ever seen that?
Yeah, well, you know, sometimes it can happen from the aggregates if there's a, you know, so I guess I don't, you know, sometimes, yes, you can see it from the aggregates where if it's near the surface and it's in a deleterious aggregate, maybe it'll bleed out in some manner and cause you that staining. But something like that, or sometimes you can have, you know, clumps of the subgrade that, you know, as the concrete's being placed, and some mud gets toward the surface, and it'll kind of give you that kind of a brownish hue or something. So I guess what I would say, I'd really have to kind of see it. It needs to kind of be looked at a little bit closer. So, but sometimes our aggregates or you know, things coming up from some grade can you know, reflect into the surface of the concrete.
I've seen reddish stains, either aggregate issues, whether it's a slag aggregate or a naturally occurring ironstone or something like that in a natural ag, whether it's the coarse or the fine. Depending on your geology, you know, may have some quantities of that up to a certain amount. Obviously, if it's exceeding the specifications for deleterious, then that's one thing, but a certain amount you might see. And then I've also seen it long-term just from the plow damage, not plow damage, but just the blade of the plow may give a rust scraping stain on the high spots of a slab from plowing. So that's, I think, most of the questions that I've seen. So I'm not seeing others. So I appreciate everyone tuning in. We know we went a little bit over. You'll get the full hour and a half, obviously, continuing education hour this morning for being on. And big thanks to Claude for your time and effort this morning. I'm going to just show the summary here. There we go. Again, this webinar was recorded, so the video is going to be posted on our website, and the handouts that you have seen from Claude from his PowerPoint show will be uploaded as well. We have another webinar coming up this Thursday on upcoming spec changes for the Mdot spec book. It's still being called a 2020 spec book, even though it's coming out in 2021. But the draft has been available for almost 6 months now. So that'll be covered on Thursday. Any MCA member eligible to from any MCA member company can sign up to attend our annual membership webinar February 17 at 9:30. We still have sponsorships available and a bunch more webinars still coming up and to be scheduled yet into March. We're looking at filling in the calendar for March 4 and March 9. So we look forward to having you folks then. And again, thanks to our sponsor, Oshkosh, and to Claude today from LafargeHolcim for his time in talking about troubleshooting. So appreciate everyone attending. And Claude, thank you.
Good deal. Thanks. Appreciate it.
All right. Take care, everyone. Hope to see you soon.